All right. Good morning again, everyone. Recording started. Um, so here's the menu for today. We are going to continue Module 5. We just passed the mid mark for Module 5, so we have about half of it left to finish. We are going to pick up exactly where we left out last time. So last time we were just looking at some refactorings. Okay, so let me grab my slides here. Oh, everything's going crazy. This is awesome. All right, well, that was different. Give me 1 minute. We're going to rewind all of this and try again. There we go. So let's see if we can make the slide go, but a little less crazy. And you know the drill. I will be keeping an eye on the chat window at all times. So if you guys have questions, please feel free to type in the chat window, interrupt anytime. Okay, you know how this is supposed to work. So going back to the slides, and hopefully this time they're not going to jump like this. There we go. All right, so what we discussed about last time, what we finished last session with, were some refactoring. Okay, so we looked at some basic refactoring. So for example, every time you say equal true, you really don't need to say equal true. I mean, if you have an expression that evaluates into true, you can just use that expression as your conditional expression for if or a while statement, okay? Then similarly, if you test something equal false, you generally don't need to do that. You just use the negation operator. So we saw all that, and then we saw also that sometimes, well, sometimes you just want to store, you know, like a value in a variable and test that, and you don't even have to use the if statement. If the whole goal of the if statement is to say, you know, if something is true, put true in the variable, then put that something in the variable, and if it's true, well, then you get true. If it's false, you get false. Okay, so no problem there. So these were the base refactoring that we talked about last time. Last one that we quickly talked about at the end of the session was this one, where pretty much the simplification here is just removing unwanted or unnecessary parentheses. Okay, they're not unwanted. If they help you get the code correct and working, please use them. Okay, so what I would like to do now is I would like to branch back here and add a little thing. Okay, I was looking for an example to make this a little bit more concrete, that precedence table and stuff like that, especially that they were a very good question in Piazza this semester. So if you haven't, check out Piazza. There was a very good question there on operator precedence that comes from the practice quiz. What I wanted to do is I wanted to emphasize this a little bit, since this has been like raising question, and I wanted to show you like side effects, okay, with the short circuit evaluation, and at the same time, you know, like try to show you kind of like what are the parameters of those kind of notations. How far can we go without making things not work? So let me grab a JGraph here real quick. So I have an empty class, empty program. What I want to do here, I want to do, well, I need a variable. So I'm going to declare a variable int n equal 42, because why not, right? And then I want to illustrate that precedence problem that we're talking about. So I write an empty half if statement here, okay? And I'm going to fill in the blank. I'm going to say, okay, first thing, n equal 2. That should raise an alarm, right? N equal 2 is not n equal 2. N equal 2 is a comparison. This is an assignment. Okay. So we know that this part of the expression, the Boolean expression, when it evaluates, is going to have the side effect of assigning the value 2 to the variable n. That's what we talked about last time, right? Short circuit evaluation, and then the combination with the assignment operator. And then I'm doing n greater than 0. So I'm trying to write this. So there are two things, right? There's the assignment that's going to have a side effect. And then the other thing that's there is that I'm trying to write this actually without, you know, those extra parentheses here. Okay, so I heard that I can simplify, so I'm going to simplify. And most of the time, the vast majority of the time, it's okay. It's okay because, here we are, the AND operator here has a kind of a very low precedence. If you look at the AND, the OR, and the XOR, exclusive OR logical operator, they have like almost the lowest precedence of all operators. What does that mean? That means that when Java looks at this expression, it's going to first group with imaginary parentheses x greater than 3, x lesser than 10. It's going to put them in group to be evaluated first, and then we are going to proceed with evaluating the AND operator. But there is an exception. The absolutely lowest precedence of them all is actually the assignment operator and all of its augmented assignment operators. So when we go back to the code here, well, unfortunately, this guy here is okay. This guy has a higher precedence than the logical AND. That means that even if I don't write the parentheses, here they come automatically put there by Java. This guy here, no, this has a lower priority than the AND. So really what I wrote is this. So highest priority operator first, this one. So I put parentheses to prioritize it. Second highest priority operator of the lot, this one. So I put parentheses here to prioritize it, okay? And then the last lowest precedence operator of this expression is assignment. So even though it looks like I wrote if n is assigned to and n greater than 0, what I wrote is if n is assigned to and n greater than 0. And that's not going to compile quite the same way. So if I try to compile that version, it tells me bad operand types for binary operator n. And that's actually a pretty clear error message if you think a little about it, okay? So this is the operator that we're talking about, binary operator logical AND, bad operand types. What is the type of this thing here on the right? Boolean. What is the type of this thing here on the left? Int. Can we do the logical AND of a Boolean value and an integer value, an int value? No, it's not defined. Boolean operators only apply on Boolean operands, okay? So if you put the parentheses like that, you see immediately that this is not right, okay? When you do not use the parentheses, when you remember that, you don't have to always use the parentheses and you try to write your code a little in a simpler manner, the problem is still there because of the precedence of operators. So that allows us to jump back a little bit to the precedence table and kind of illustrate, how things can go wrong based on precedence. Then there's another example that I just added this morning that I think is going to help you guys wrap your head around all that stuff. Are there situations where that kind of bug can go silent? And what I mean by going silent is the bug is still there, so it's going to do something wrong, okay? However, the compiler is not going to be able to catch it. That's what I mean in this context by a bug being silent, okay? So let's try to play a little bit with a Boolean variable. So I'm going to call my Boolean variable stuff because I'm running out of imagination for names. I'm going to put false into it, okay? And now what I'm going to do is I'm going to try to craft the same kind of if expression that I had up there, but this time using also the stuff variable. And I'm going to assign a value to the stuff variable. So here we go, if, so this is an empty half if statement. And the same way that I did n equal 2, I'm going to say stuff equal, what did I pick? True, yeah, true. And n greater than 0 because why not, okay? So I'm not worried about the n greater than 0 like we saw, okay? This is the highest precedence operator in this expression, so n greater than 0 is going to be automatically encased into imaginary parentheses by Java, so that is going to be evaluated first, okay? That one is going to come next, so that means that this is going to be encased in parentheses, okay? And finally, the assignment operator. So what I wrote here is really stuff is assigned expression true and n greater than 0. Well, here's the thing is that even though it's most likely not what I wanted to write, okay? It's kind of a little weird expression there. If I try to compile it, it's going to tell me, well, it's still going to tell me bad operands for that one. So I might as well comment it out. There we go. So if I try to compile without the first one that obviously had a syntax error, then the compiler tells me, you're okay, you're fine. I can make sense of this. That's what it means, right? I can make sense of that. Maybe I'm not understanding exactly what you wanted to tell me, but at least I can make sense of it. It's correct Java. So what's the difference here? It's all about, the operator and the data type of the operand matching. That's what the compiler does. It tries to constantly match, make sure that you're using the right data types in the right places. So here what we have is, let's start here. We have n greater than 0. This is a Boolean expression. The comparison is going to return true or false. Well, perfect, because it's the second operand of a logical AND, and a logical AND needs two operands that are going to be Boolean values. This guy here, it's a literal. It's a literal value of Boolean data type. It's one of the two possible literal values that are Boolean, true or false. So this one is true. So this is of data type Boolean. This, when it evaluates, is of data type Boolean. The AND operator is perfectly happy. And this is what was wrong with the previous one. What was wrong with the previous one is that the AND operator, let me put back the parentheses here, the AND operator was applied between this thing here, which was an expression, so a Boolean value was coming out of that, and this thing here, which was an int. So wrong data type, int, I need a Boolean, I don't need an int. So here, the AND operator is happy. So we evaluate all of this, and what do we get out of a Boolean expression with logical AND operator? We get a Boolean value, okay? The Boolean value is assigned to a variable, okay? Checks and balances. The data type of the value being assigned is Boolean. What is the data type of the variable? Well, look at this. It's a Boolean variable. So compiler is happy. So the result of this is really weird, actually. The result of this expression is that we are going to assign to the variable stuff a value, okay? So how does that fit in an if statement? Well, keep in mind, an assignment is both an expression and a statement. So assignment is going to change a value of stuff. That's the statement part of it. And also, this expression here that is an assignment of a new value to stuff is going to also result in a value of its own, yield a value. What is the value? Whatever value is assigned to stuff. So let's go back here. What are we trying to assign to stuff? So true, well, true is true. Okay, that was easy to evaluate. Logical AND, so remember the short circuit operation, right? With a logical AND, if the first part is true, I still need to check that the second part is true. Okay, because if it's false, then the whole thing is going to be false. So now I check this. N greater than 0 is, in this case, is it true? Yes, it's true. So true and true, this expression here evaluates to the value, the Boolean value true. This is what is assigned to stuff. So in memory, the variable stuff gets true instead of the false that it had originally. And now the expression results in whatever Boolean value I just assigned to stuff, which is true. So that Boolean condition for the if statement is true. If I want to double check this, system.out println, it is really true. Okay, and just for the sake of being paranoid, it should never run, but system.out.println. So if we get there, something is wrong. Okay, we need to go back and figure out exactly where we took the left turn at Albuquerque. All right. So let's save this. Compile it. Run it. It is really true. Okay. So what's important is, so first level of understanding all of those mechanics, short circuit evaluation, the fact that an assignment is also an expression that returns a value, the precedence of operator, all of those things are kind of mixing together in that example. So that forces us to catch up on the last thing that we covered, as well as a few things behind. So it's good repetition, it's good learning. So understand all of those technical things, and then understand maybe the most important lesson, which is you can write perfectly valid Java. This is a valid Java program. It compiles, okay? And most likely it's not actually conveying the meaning that you want. So there is a difference between the syntax and what we call the semantics. The syntax is just the correctness of how you phrase things in a language. The semantic is actually the meaning of those things. So what is the meaning of that if expression? Well, again, probably not what you wanted to do, except if you are already thinking, those kind of expression, in which case, you know, that this chapter should be very easy for you. All right. Okay. So let's move on. So this was what we covered really fast at the end of the last lecture. So I wanted to go back over it and add a few more examples to make sure it's clear. But now, since we are talking about, you know, still talking about refactoring, and let me move that guy here so that we can see the stuff. There we go. So now what I would like to do, would like to look at a certain structure of if-else statement. So you got it here as a top. I'm going to grab my laser pointer here. There you go. So we have a if, then, else, and if. Okay, so this is just pseudocode. So we have a if with a first part to execute when condition is true, and a second part to execute when condition is false. Condition 1 is false. So the code that we do here, we're just going to call it, sorry, do number 2. Whatever it does, I don't care. It's just pseudocode, right? And then inside the part to execute when condition 1 is true, I have another if statement with another condition that's going to execute either do number 1 or do number 2. So we have this part of the code here is duplicated. Okay, do number 2 is the same series of statement. So the first thing I would like you to do, check out that little piece of code and tell me what I need to put in this Boolean truth table right there. Okay, so I pre-filled the truth table. We have 2 conditions. Each condition can be true or false. So here's what happened when the condition 1 is true. The condition 2 can be true or false. Here's what happened when condition 1 is false. Condition 2 can be true or false again. So which of the blocks here, do number 1, do number 2, am I going to execute in order in each of those possibilities here? So first answer, this one is going to be do number 1. Okay. What about this one? So true and true. How do you figure that out? This is true. I go here. This is true. I go here. Tracing, right? So we are just doing a quick tracing practice here. So do number 1. What about this one? Number 2. Awesome. So jump here and then jump here. What about this one? Condition 1 is false. That's going to be do number 2. Yeah, condition 1 is false, jump here, right? Do number 2. Perfect. And then if both are false, well, here's the funny thing, is that condition 1 is false. I jump here. I don't even check condition 2. But the truth table tells me, yeah, there is a possibility that condition 1 is false and condition 2 is false, at least theoretically, right? So that doesn't matter. That false here or that true, for that matter, doesn't matter. Both of those cases, I'm going to do execute the block of code, do number 2. Okay, perfect. All right, so we all remember how to trace through a bunch of nested if statements. That's awesome. Here is the second block of code I want to show you. Well, if you think about the table that we just looked at, it kind of looks like a OR table. Okay, we don't have true and false in the last column. We have do 1 or do 2, but the pattern was exactly the same. As a matter of fact, if I say, okay, so, sorry, not an OR table, an AND table. If I say, well, since the table looks similar, that means that I could rewrite this if-else statement that way, okay? So using an AND logical operator between condition 1, condition 2, executing block do 1 if it's true, executing block do 2 if it's true. If I come up with this hypothesis that I can refactor my code and write the same stuff in a simpler manner using a logical AND operator, then I just have to do the truth table of both versions. And if the truth table of both versions is the same, so it's kind of a truth table between quotes because here I don't have true, false, I just have the outcome, right? But if the two truth tables are the same, then those 2 pieces of code behave the same way. So this is another reason for which we write tests. Okay, this is another reason for which we learn about truth tables and stuff like that to understand all the possible outcome that can come out of a Boolean expression used as a condition, right? We have a very rigorous way here to actually compare those 2 pieces of code and determine without a chance of failure what if they are equivalent to one another or not. Okay, so this is one that you guys did for me in the previous slide, like a minute ago, right? So true, true, that means do one. True, false, that means do two. And then as soon as the first condition is false, we do two. Well, then I propose this refactoring. And the goal of refactoring is we do not change the behavior of the code at all. But what we change is how it's written. So yes, I did write it differently. My hypothesis is that I can replace the structure by just one Boolean expression that's a little bit more complex with a logical AND. And there you go. If condition 1 and condition 2 do 1, else do 2, I do the truth table for this. When condition 1 is true, there we go, and condition 2 is true, then I'm going to execute do 1. Perfect. When condition 1 is true and condition 2 is false, then this whole expression is going to be false, right? So I'm going to execute do number 2. Same thing when the first one is false, condition 1, and the second one is true, the whole thing is going to be false. So again, go to the else statement, execute do 2. And if both of them are false, which is the last case here, then of course, again, I go to the else. There's only one scenario in which I go to the first part of the if statement and I execute this code, okay? All right, so so I refactored code that is maybe a little bit more complex, and I proved pretty much that it's equivalent. So is it really simpler, the version at the bottom compared to the version of the top? This is one of those your mileage might vary situation. The one at the top, obviously, is more complex, I would say, from a structural point of view. We use two if statements, right? They are nested into one another. Here, there's just one flat if statement. So in terms of the number of if statements, yes, it's more complex at the top than the bottom. But here, what has been absorbing this complexity is actually the Boolean expression. So the Boolean expression is no longer just a comparison. It's actually a full-fledged Boolean expression with two terms and a Boolean operator, logical operator in the middle. So the complexity didn't go away. So sometimes it's easier to write things like this. And then suddenly you pile up more and more logical operator, and suddenly your Boolean expression becomes very large. And at some point you're thinking, well, you know what, maybe I would understand my code better if I wrote it like this with a structure, okay? And sometimes it's a little bit of column A and column B, which means that you want several if statements to make your code more readable, but at the same time, for things that are like using only one Boolean operator, they're still easy to track, just by reading them. So you want to simplify a little bit the code, maybe by putting a composed Boolean expression here, and so on and so forth. Okay, so it's a total trade-off. Use this approach and use this approach, combine them. The goal is to get something that a piece of code that once you add a few comments here and there is really easy to understand. So I want to be able to read your code and read your comment and understand what is going on here without having to do the truth table, without having to trace. Okay, that's when you get readable code. So all right, so we did a very simple refactoring here. Interesting thing about this refactoring, the way that you write the code doesn't change all possible outcome, at least in theory, but it may change a little how you test it if you are trying to do, for example, code coverage, and more specifically, if we are interested in doing branch coverage. Okay, so branch coverage means it's a part of code coverage. I mean, I want to execute all of my code, right? And more specifically, I'm paying attention to make sure that every branch, the then and the else of each if statement is actually executed when I test. So when you're testing with condition, well, truth table help you figure out what you have to test. Take a look at this example here. So based only on what we talked about regarding test before to introduce Boolean truth table, right? What I would say here is that I have three possible outcomes to this code. Okay, there are three possible if then else branch that can trigger. The first one that can trigger is, well, let's start with the easy one, the else. So that's one, okay? And then if this condition is true, there are two possible branch that can trigger. That's one, that's two, that's one, that's three. So that's it. I know that I can achieve code coverage for this little snippet of code by just having three tests. One test that is going to trigger this, one test that is going to trigger this, one test that is going to trigger this one right here. Okay. Now let's look at our refactored version. So refactored, again, it's exactly the same code, right? It behaves exactly the same way. We cannot formally demonstrated that with the truth table. Well, the interesting bit about this is that, I need to move that guy again. All right. The interesting bit about this is that I cannot move myself. Is it really interesting? Not really, but yeah, there we go. All right. The interesting thing about that is that if we apply that logic of code coverage and branch coverage, I have only two branches. So that means that based on what we said before to introduce truth table, I could test completely this code by just having one test that's going to make this expression become true and just trigger this part of the code, and one making this expression become false and thus trigger this part of the code. So as far as branch coverage goes, that code looks even simpler to test. Okay, so the thing I want to take into consideration now that I know about Boolean expression is that in practice, it's very possible that in practice, I need only two tests, okay? But in theory, because I have a logical AND here, that means that the combination of those two conditions can have four possible outcomes. True, 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 false, false, true, false, false, right? So this is where we have to talk about different types of code coverage, okay? Like if I'm obsessed about doing branch coverage, then two tests are okay. But the thing that those two tests are not taking into consideration is that depending on what the code is doing, depending on what are the value that I use for those condition one, condition two, I may theoretically have like four possible scenarios. So it would be wiser to test probably all the four possible scenarios here when condition one and condition two are true, 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 false, false, true, false, false. Okay, so I have four tests, and those four tests are going to take care of giving me what I call decision coverage. I don't think this is an official term for it. This is just what I'm going to call it in the course, right? Decision coverage means that every time I have a Boolean expression, to make sure that I run all possible execution paths, in my code, I am going to check out what are all the possible outcomes of that Boolean expression, and I'm going to craft a test that correspond to each of them. So a test that is going to make condition one true, condition two true, and then another one that makes them both false. Okay, and once I have those four tests, then I can use them with this version of the code or that version of the code, and I will get full code coverage. Okay, so if you're not sure how to get full code coverage, then definitely for Boolean expression, use this. Now, what will happen is that sometime one of those theoretically possible scenario doesn't happen in practice. Like, for example, if my condition is, I don't know, if the number modulo 2 is 0, so if it's even and it's greater than 0, well, if I don't allow, for example, negative number, then there's some condition in my expression that can never be false, like, and it will always be greater than 0. So given the constraint of your code, given like other factors that are not just the formula by itself, the expression by itself, you may have some of those cases that are not actually going to occur in the wild. So then you can argue, well, if those cases never happen, why do I test them? Again, it's a matter of fairness, okay? You are going to make sure that you cover all of the possible execution path of your code. And then if you realize that one test cannot be written because that specific scenario is never going to happen, so be it. You just mark it here, cannot happen, and you're done. But you still did applied due diligence, okay? You went all possible way to spin around your code. What about this one? So I'm going to preemptively move this guy around. So now I have three if statements. If condition one, then execute all this, else execute this. The first block is another if statement that tests condition two. If condition one is true and condition two is true, then I do statement number two, okay, override statement number one. And then this condition here is still, this if here in the else part is still an if that tests condition two, but this time it does block one if it's true instead of block two, and block two if it's false instead of block one. So take a minute And you can do the truth table. Actually, I really recommend that you do really quick, the truth table for this. So maybe start with the truth table. And once you have done the truth table, make me a suggestion, give me a suggestion for refactoring. How could I rewrite this three if statement piece of code that are nested into one another using only one if else statement? And I'm going to put just 3 minutes on the counter. So if you have problem doing the truth table, just let me know. Okay, I'm going to put a timer so that we don't go endless here. If you have problem doing the truth table, let me know. If you have problem figuring out after you've done the truth table, you know how you could simplify this. Again, use the chat window. Good hypothesis. Okay, so one hypothesis in the chat, hey, can we replace that with the logical OR operator? Another hypothesis is exclusive OR. Well, there are three logical operators: logical AND, logical OR, and logical exclusive OR. So now the question is, how do we make sure that we're using the right one, right? So out of the three operators, AND, OR, and exclusive OR, which one should I use? So I can always check out the truth table of each of those operators. They are in the slides, okay? So you guys can rewind a little bit the slides and check it out. But what I need to compare that to is the truth table of this guy here. So again, give me a truth table for this if, then, if, else, if piece of code. And then we'll be able to compare it to the other truth table, and that will tell us exactly which logical operator we can use. I'm trying to get you a kind of an intuition about what truth tables are good at, what they can help you decide with 100% certitude. Can we post a screenshot? No, I see. What is a C of the table? Screenshot. Okay. All right. So yeah. Okay. Give me 1 second. All right. I'm going to disappear for 1 second, and I'm going to do a quick slide to help you guys with like the form of the table. Okay. Short answer is it's not in the slide deck, so I have to improvise it real quick here. So I'm going to take long. Okay. Go copy this. All right, that should work. So save it. And we are back. So we are back, we're back. Hold on, one more thing. Sorry, I almost messed up. And our timer is done. So don't worry about the timer. We are going to just remove this real quick. Okay, so this is what the truth table should look like. So eventually we're going to have a bottom version, right? So we're going to write down the truth table for the top version. So how many entries do you have in your truth table? Well, how many conditions do you have to check? Okay, if that's been kind of holding you back, you were not sure how many columns, you're going to have one column per condition. Okay, and then if you were not sure how many rows, well, if you have two columns, then it's 2 to the power the number of columns, each column representing here one of the expression. And I realize that my laser pointer is not on. There we go. So, so then you enumerate all possible cases. When condition 1 is true, there are 2 possibilities. Condition 2 is true, false. When condition 1 is false, there are 2 possibilities, true, false. So right now we have only the top version. So let's fill in those things here using our tracing skills. So what do I put here? Did I lose my pointer? There we go. So let's start with this one, okay? Given the code at the top here, we have only the top, code at the top. What do I put? So, okay, good. I get some answer there. So true, true, I'm going to say do number 2. So this is true, right? This is true, I go here. This is true, I go here. Perfect. Then true, false, do number 1. True, I go here. False, I go in the else, do number 1. Yeah. False, true, false, I jump here. True, this one is true, I do number 1. False, false, I do number 2. This is false, I jump to the else. This is false, I jump to the else, do number 2. Perfect. Okay. So now that we have this truth table, so it's going to tell me, and again, I should put air quote around truth table because it's not truth value here, it's just do 1 and do 2. But now that I have do number 2, do number 1, do number 1, and do number 2, so 2, 1, 1, 2, what does this look like? Can I make a sure-foot decision now on which logical operator I could use to simplify this whole thing into a single if statement? So don't hesitate to go back and go back a few slides ago, in the PDF, check it out, and tell me which operator you would put here. And again, when we do things like that, keep in mind, right? If I get the correct answer in the chat, I'm happy. That means that at least some of you are already comfortable with this. But more importantly, if you are stuck, if you don't know where to start, you should really say something in chat window so I can, detangle this for you. That's the whole point of doing it together, right? So I'm expecting more questions actually than just the final solution. So would it be an and? Okay, so let's go and take that as an hypothesis. Okay, so if I have true and true, and is true. Okay, so assuming that I have do 1, do 2 in this order in my new if statement here that I'm going to write in a minute, that would be do 1. I'm going to say do 1 is true, do 2 is false. So that just depends on where I put them in the if and else, or if I swap them around. Okay, so this is going to do 1. What did we have here? From the previous post in the chat, we had a do 2. So I can already rule out the logical and. But that's more importantly, that's how I would do it, right? There's nothing wrong with saying, okay, is it and, is it or, is it XOR? You can take them in whatever order you want, but this is going to be how you decide. So a logical and here, true and true give me true. I'm going to assume that I'm going to write my if condition 1 and condition 2, then do 1, else do 2. And there I can tell you that it's not some matching because there is a do 2 here and there is a do 1 here. Does that make sense? Here, if that helps, it makes sense. Okay, cool. So if that helps, I'm going to put a 2 here. I'm writing with a mouse in case you guys can tell, so this is going to be horrible. So I'm just going to use like Roman numeral, right? So there we go. I have a 1 or a 2. And what I'm saying is that if I write if condition 1 and condition 2, then do 1, else do 2, right? In this case, I would do 1. So forget it. This is not good enough. Okay, this is a match. I don't even need to do the other ones. So if it's not the and, let's move to the logical or. Okay, so true or true. So true or true, that's going to give me true, right? So if I write if condition 1 or condition 2, then do 1, then I'm still executing 1 here. And I need to execute do 2. So it's not going to work. Okay. So I ruled out the logical and. I ruled out the logical or. And I didn't even have to do much, okay? I just had to look at the first row of my truth table. What's left? That guy here, the little hat symbol, XOR, okay? So if I look at the XOR 1, so the truth table for XOR is different, right? I told you the easy way to remember it is to say the XOR is going to be true when both operands, Boolean operands, are different. Okay, that's what I gave you as a little trick to remember it. So that means that here they are the same. So it's going to be false. False means I'm going to execute do number 2, right? Here they are different. So I'm going to execute do number 1, execute do number 1. Here they are the same. I'm going to execute do number 2. There we are. Okay, all of the lines here are actually matching, which means that those two versions are actually compatible. They are equivalent. They have the same meaning. Okay, so there we go. If I pull up the original slide, okay, so I can replace all of this code here by a simplified version that is using one if statement with one Boolean expression that has just one logical operator added to it and uses the condition 1, condition 2 as operand. So no, the logo, the symbol for XOR is, so this is, okay, let's try with the fingers. This is the AND, this is the OR, 2 bars, okay? And the XOR is the hat. So on my keyboard and on most keyboard, it should be Shift 6, okay? And the pipes, vertical pipe, are above the Enter key normally. All right, so these are like the three symbols that we use in Java, but also in a lot of modern programming language, okay, besides Java, to represent the logical AND, logical OR, and logical XOR. Make sense? All right, last one. Well, you guys know already where I'm going, right? I made you, I worked with you through the logical AND. I made you figure out the XOR, the exclusive OR. So the only thing that we have left pretty much is a situation where we can refactor this set of two if statements nested into one another using one logical OR. So here it is. Okay, so I'm going to propose, this is where I see the exercise going first off, okay? Testing skills, I guess, guessing the multiple choice without understanding the stuff. And then I look at it and I say, okay, now I want to establish for sure that this is equivalent. So I do the truth table, okay? When this condition is true and this condition is true, then I execute this guy. There we go, this is here. When this condition is true and this condition is false, then I execute this guy, etc., etc. Okay? So I'm going to write like the truth table for, and actually this one is messed up here. Do number 1, hold on, do number 1, do number 2 here. It should be do number 2. Oh yeah, no, sorry, I was misreading. Yeah, no, the table is not wrong. It's my brain that is not right. So that's going to be harder to fix my brain than to fix the table, but we'll try to make it work. So let me erase this so that I don't confuse you more and unnecessarily. I was jumping in the else instead of going into the first part of our if statement. So first line here, I have true and true, okay? And I'm going to just execute do number 1 in the code over there, okay? So that's the part that I messed up. Sorry about this. So I execute this part here. Oh my God, this is like, this pen is working on me half of the time. I don't know why. All right, so I'm executing this part. So this row here makes me execute this part. The second row, true and false. Well, since I don't use, when this is true, condition 1 is true, I come here again, and I don't use condition 2 at all. This is going to give me the same outcome. So the top version gives me do 1, then false is going to make me jump to the else. Condition 1 being false makes me jump to the else. Condition 2 is true. I'm going to execute do 1. Condition 2 is false. I'm going to execute instead do 2. Okay, so that's my truth table pretty much for the top version, and the bottom version is just the logical OR operator. So true and true gives me true. So assuming that I say if condition 1 or condition 2, then do 1 else do 2. Okay, true and true is going to give me true, so I'm going to execute do 1. True and false is going to give me true again, do 1, do one again, and only if I have both condition false, I'm going to execute the else part, which is do number 2. Okay. So then when I check, once I check that those two things match perfectly, then I can tell that those two pieces of code are perfectly equivalent. Okay, with 100% certitude. That's the thing with truth table. Okay, our first reflex is very often, too often, to try to guess our way through a problem. Okay, that's not safe, especially when you are a beginner, a novice, right? So instead, you do the truth table. Does it take a little bit more time? Yes, at the beginning, and then you become good at it, and it doesn't take as much time, but it gives you 100% certitude that you get the points as an exam, for example, right? Replace that by trying to guesstimate. You can guesstimate for like half an hour, and you still don't know if you got it right or wrong, right? So just be wise during the exam, okay? Invest that 5 minutes doing the truth table during an exam, a quiz, etc., so that you have a 100% correct result, and then move on to the next step, okay? All right. Over conditional statement in Java. So we are done with refactoring. Well, I misspoke. We are done with this kind of refactoring. Now we're going to do a different kind of refactoring. We are going to mostly use different syntax to convey a conditional statement in Java. I think that's a fair way to summarize what's left in this module. So let's take a look at what I mean. So the first new syntax that I'm going to introduce is called ternary conditional operator. So it's an operator, right? Actually, that's an operator that's written using 3 symbols. That's kind of weird. But it's an operator. It's a conditional operator. That means it allows us to test an expression. And my Boolean expression is going to be somewhere in here. Okay, there we go. Boolean expression right here. So it's going to allow me to test a Boolean expression. And then, depending on whether that expression is true or false, I'm going to evaluate this expression if the first one is true. If the first one is false, then I'm going to instead evaluate this expression here. Okay? So that's the general syntax. A pair of parentheses here, here, around the Boolean expression. That should not surprise you. Every time we use an if statement or a while statement, we always have parentheses around the Boolean expression. But then we have this question mark followed by the expression that we're going to evaluate if the condition is true, and then a colon followed by the expression we're going to evaluate if the condition is false. So it's a little bit of a weird syntax, but I'm going to explain to you what it corresponds to. Okay, so first let me clear this up. There we go. And let's take a quick example. So here's a piece of code, x equals 0, y equals 0. And by the way, if you did your reading assignment, you already know that. But just in case you missed it in the reading assignment, when you declare actually Boolean, sorry, not just Boolean variable, when you declare any variable, like for example, int n equals 42, let's say I want another variable, int x equals 0, and then double something equal 1.2, and double something else equal 1.4. Okay? So when I have like multiple variables like that, what I encourage you to do is always declare one variable per line, and so that you can put a nice little comment here telling me what this variable is about. Okay? Same thing here, same thing here. But one other notation that you're going to see very often used by programmers is that if you declare multiple variables with the same type, so int here and int here, right? You can declare them together in one line by saying, I want an int n initialized to 42, and just by separating with a comma, int x equal to 0. Okay? So that makes it a little bit awkward to comment on the same line, you know, but this is a notation that's very common, so you need to get used to it. You're going to see it often, okay? And you can do that with any data type, and you don't have to stop at 2 variables. If you have more, then keep going, right? Comma, nothing equals 0.0. All right, you keep going like that, and this is going to declare 3 variables, nothing, something else, or something that are all of type double. Okay, so just a quick side note here because we use that expression, that notation here. All right, So we have int x equals 0, y equals 0, two variables declared and initialized. And then we test if x greater than 0, then y equal 1, else y equal -1. So this is a situation where the ternary conditional operator allows us to write things a little bit simpler. Okay, what's happening here is that we are assigning 1 to y if the condition x greater than 0 is true. And we are assigning -1 to y otherwise. So we always end up assigning something to y, right? That's the thing that's coming out of this piece of code. We are going to assign a value to y, to the variable y. The value that we assign depends on what the truth value of this condition here, x greater than 0, is. So what we would really like to write is something like this. Okay, and I'm going to switch real quick here. I'm going to clean up this code a little bit because we have all sorts of examples from the beginning of the lecture. There we are. Okay, so what we would like to do is something like int x equals 0, y equals 0. Okay, so this is what we had in the slide. And now I want to say I'm going to assign to y a value. Okay, an expression, the result of evaluating an expression. And that expression should be a conditional. So I should do if x, so what was it, x greater than 0. If x greater than 0, then I want this whole expression here to be equal to 1. Else, I want it to be equal to -1. That's what we had, okay? So there are some language that considers the if statement as also an expression. If you consider the if statement as an expression, you would evaluate it and you would say, okay, x greater than 0, is it true or false? If it's true, then I yield the value 1, else I yield the value -1. And when I say I yield, that means instead of this whole expression, right? And you would be good to go. If I try to write this in Java, okay, it's not really like going like smoothly, right? So Java doesn't consider the if statement as also an expression. So you cannot use it inside an expression like that. But Java instead offers you another syntax that is a ternary conditional operator, where you can just put your condition, then question mark meaning is that condition true or not. If the condition is true, here's the value I want my expression to yield. If it's false, else, the else is colon, this is the value I want to yield. Okay, and if I write this, and Java is more than happy to compile it for me, and when I run it, I can do system.out.println y to see what the result is at the end. When I run this, in this case, I'm going to get -1. So let's see, x is 0, so x greater than 0, false. So this whole expression here is going to be equal to this part, -1. And you don't have to put just literals here. You can put whatever you want. You can put any expression involving assignments, even side effects, involving coding method, etc. Any expression that results into a value that can be assigned to y is going to be a good fit there. Okay. So in this case, y is an int. So this and this must be two expressions that are going to yield int results. Okay. So it's just a convenience. It's just like what we call syntactical sugar. Okay, this is the jargon term for this kind of stuff. It's just syntax that allows you to rewrite code slightly differently. Okay, and once you get used to it, once you get used to the ternary conditional operator, then this notation actually is easier. It's easier because you see that you are going to do one thing, assign a value to y, and then that value depends on a condition. It's either that or that, and that's it. Okay, so it's a little less cumbersome than writing a full if-else statement. Question in the chat. So is this the same as if-else, but you can only execute two things maximum? No, it's not the same. I mean, conceptually, it's the same as an if-else, okay? But it's an if-else used as an expression, first thing. And then does that mean that I can only have two? I would say, unfortunately not. You're going to see exactly what I mean. let me take an example here live to answer your question, okay? So let's say that we have a piece of code that says if, so I'm going to write the full code first, and then we're going to translate it, okay? So if x modulo 2, we have been using that example so many times, that should be super familiar now. So we test first if something is actually even, okay? So if x modulo 2 is 0, there we go. And if it's even, then I'm going to do, and I'm going to write one with like two if statements nested. So then I'm going to say if x is greater than 0, else if x is not greater than 0, do something else. And in all of those cases, I'm going to assign a value to y, okay? So let's say that if this first case happens, I'm going to say y is 1. I'm going to make arbitrary numbers, okay? Otherwise, y is going to be 2. So the number inside of y is going to tell me pretty much what happened here, if x is even and greater than 0 or not, okay? And then here, I'm going to have the same thing than here, so I'm going to cut and paste it. And except I'm going to put number 3. So before I go any further, okay, let me know if that doesn't make sense. It's kind of arbitrary. So yeah, deal with it, like bear with me. Sorry about that. It's a totally arbitrary, a little bit abstract example. But I'm saying if x modulo 2 is 0, so if x is even and greater than 0, y equal 1. If it's even and not greater than 0, I'm going to put the code 2 in the variable y. And then if it's odd and greater than 0, that's going to be code 3. Odd and not greater than 0, code 4. Okay? So the whole goal, again, I can spot here that everything that I do is only one thing, which is assign a value to y. So that makes it a good candidate to be rewritten as a ternary conditional operator. So let's just do that. I'm going to do this a little bit up. I'm going to say here is I'm going to say, so y is assigned and an expression. All right. So let me put this expression into parentheses because it's going to get nasty. So my first expression, I want to capture that if statement. So I'm taking the condition here, right? There we go. And I learned that the ternary conditional operator is just about putting the condition, question mark, and then something here, and then else something here, okay? And then that's it. That's my expression, okay? So this is how I would rewrite that first if statement, except that the value that I want to yield if that condition is true, I don't know it yet. I have to do another if statement. So can I nest a ternary conditional operator inside another ternary conditional operator? Absolutely. So now we need to write this in a way that is semi-readable, okay? So I'm going to go to the next line. I'm going to say, okay, this is what I'm going to do to return if this condition is true, okay? And this is what I'm going to return if it's false. So this is, I'm kind of indenting this as an if-else statement, but instead of using else, I'm using colon, and then I'm using this following the condition for the if. I think I can get rid of this parenthesis here. I'm not going to need it. It just makes things even worse. And this is the end of my if-else statement, okay? So the first xxx here is going to be replaced by this. So the logic of this, again, I'm going to write a ternary conditional operator, right, is if x is greater than 0, question mark, what is the value that I want? 1. Else, I wanted 2. Okay? And then this one, if x is greater than 0, I don't know why I have an extra space here. Let me fix that. Okay. Then I'm going to return 3 or 4. That's why I said unfortunately. Okay. So we can nest ternary conditional operator, and we are going to get exactly the same result. Okay. That doesn't mean we should nest ternary conditional operators. All right. For here, like for this example, I've been like breaking down, into 1, 2, 3, 4, 5 lines just to make it a little bit more readable. if I'm not 100% sure of the priority of operators, and honestly, in this case, I'm not 100% sure, I don't remember how the ternary conditional operator ranks, I'm going to add parentheses here. And then if I don't want to have this wonky, weird indentation for something that is still not an if statement, then I'm going to probably put everything together like that. But then, like, readability-wise, my colleagues are not going to like me, okay? They would much prefer probably seeing something like that than seeing something like that, or at least, have like a first if else for modulo 2, x modulo 2 equals 0, and then if I want to replace this by a ternary conditional operator, okay? So this is correct code. I mean, there's no argument here that this is exactly the same code. We can do tests on all possible outcome, to assess that more formally, but then you have to ask, whether it's more readable or not. Question in the chat. So in an if else, I could print something, increment a variable, call a method, etc. But for the ternary, you can also do multiple things like that also? Unfortunately, yes. So for example, this is a good question. Okay. Those questions are going to end up showing you the ternary conditional operator in all of its gory splendor. So let me erase that old version here, okay? So let's say that I have another variable here. I could absolutely have something like result equal 1 here. And again, I parenthesize to avoid, introducing a bug because of the precedence of operator. So I could have a side effect. Could have a side effect in one of the expression that I want to yield. Okay, I could have a side effect even in the conditional expression. Okay, so I could say, for example, Boolean stuff equals false. That condition here could be, for example, stuff is assigned true, which is kind of weird. Okay, but yes, I have an assignment, and this assignment is putting the value true in the variable stuff, and then this whole expression yields the value true. So this condition is going to be always true. Therefore, I'm going to always return this, and this assigns value 1 to variable result, and then the value that is yielded by this expression is 1. So this is what would end up inside of y. So yes, you are doing a good job here, looking at this and saying, okay, what can I possibly do? What can't I possibly do? And so far, the answer to all of your suggestions has been, yes, you can do it. Okay. Again, you know what I expect in this class, right? In this class, I expect that you need to absorb this knowledge. You need to understand what I'm talking about. And the quiz and practice quiz are going to help you make sure that you are able to sort out this kind of code. Okay. So we are going to practice that skill, that part of your skill. Now, during an exam, a timed exam, like the final, etc., when you have to write code, I would much prefer for you to write a bunch of if statements if that's what you're comfortable with, and get your code to work. And then if you realize that out of 2 hours of time for the exam, you still have 1 hour and 45 minutes left, please feel free to refactor. I have no problem with that. You can then, spend the remaining time trying to come up with a neat formula like this. But the bottom line is you get it to work first. And then you don't have to use those notation when you write code in my exams for this first introduction to programming class, okay? But you need to be able to read them, trace them, understand them. That absolutely, okay? So if I was giving you a piece of code like this and I'd say, can you please rewrite it for me? Can you refactor this in a way that is a little bit more readable, okay? Yes, you should be able to do that. You refactor it, you write it like simply, more in a more simple manner, but you understand what the heck was going on here, okay? Does that make sense for everyone, both the content and actually the expectation? Okay, I don't want anybody to lose point at the exam because they are trying to write complicated things. Sometimes, just write it simply. Not sometimes, all the time. Write it simply, get it to work, and then you can complicate, okay? All right, cool. So this last example here on the slide, no, this is not the last one, sorry, this is before the last. So this is showing something similar, an if-else statement. But this time, I'm not assigning something to a variable. I'm displaying something on the screen. Hey, Sam. So I'm displaying something on the screen, first part of the if, I'm displaying num, whatever that variable is. I'm expecting it's an int, right? Num concatenated to is even, or num concatenated to is odd. Okay. Well, what I'm trying to show you with this second example here is that it doesn't have to be that you assign, a value or as a result of an expression to a variable. You can actually have an expression here that you just want to display. Okay, so here these are two different expressions you want to display. Which one do you want to display? It depends on that condition. Okay, so right, so into refactoring that and making it look better with the ternary conditional operator, this is what I would get: system.out.println. Okay, so I factor out of the conditional, the call to the method, and what I'm passing to the method is check this condition. If that condition is true, then this whole thing here is going to be replaced by num plus is even. I cannot use the mouse, sorry. And then if it's false, it's going to be replaced by num plus is odd. So it's the same logic, okay? And I heard a ding, so there has to be a hand raise, something like that. Yeah, go ahead. What's your question?
Can you hear me?
Yep, I can hear you.
So in the ternary expression, you're doing a common thing, right? So the time you're saying system out println is the common, I guess, execution,
Yeah.
right? Is there ever a case where we use the ternary and there's not a common execution? So like instead of left, you can say equal to y, right? Or and then whatever it is. But do you say or else x equal to -1?
Now, if I understand your question correctly, there's never a case where you are not, like, for example, here. Sorry, touch screen. Okay, let me grab the pen and do the mouse instead. No, it's not going to work. Sorry, technical problem, user error. All right, so in this case here, yes, you factor out the system.out.println, okay, that is here and here. And then if you look at the other example, we did the same, we assigned something to y. And you always need something like that because the core of the ternary conditional operator is, depending on this condition here, okay, I want one value or another value. I want one value or another value. Okay, so that's the only times where you can use the TCO, pretty much, the ternary conditional operator. In this case, we could go a little bit further. We could say, I want to factor more stuff out of my system, out of my if statement. So system.out.println. Okay, and then I'm going to say I want to display always num. Then I want to display num concatenated to the string space is space. Okay, and then I want to concatenate to that, and this is when it's going to change, right? It's going to change based on whether num is even or odd. So then I would use here a ternary conditional operator. I would say num modulo 2 equals 0, question mark. So if that is true, then I want to concatenate even, else I want to concatenate odd. Does that make sense?
It makes sense. You're still using the system outprint as a common
Yeah, yeah.
factor, essentially. You're just giving
And
it a logic gate, right?
to go further into your question, I also factored out this part because yes, it was common. It was always num plus even plus is even here, num plus is odd here. I don't need to repeat myself. Okay, there is a principle in programming called DRY, drive. Don't repeat yourself, right? And we're going to talk a lot about it in COP2513. But right now, we are still encountering. We start to encounter a situation where we can refactor and avoid repeating ourselves. It's always good to not repeat yourself. Okay?
Okay, thank you.
All right, cool. Good question. All right. So going back to the side, so there was only two examples. I got it wrong. So there was only two examples on this slide. So assigning to a variable or, using how to say, call to a method. Both are working, right? This one is going to be easy. This one is purely aesthetic. So it's not really a different syntax. It's just that when you have a bunch of if-else statements like that that cascade with one another, right? The only thing that I want to point out to your attention is that in this case, it's even more obvious because I don't need the curly brace, so I can remove all of those extra curly braces, right? And then I can reindent things so that all the else are aligning with the first if statement. That doesn't mean that all those else attach to the if statement, right? This if statement here has an else here. This if statement here has an else here, etc., right? But it's just a very common way that the programmers are going to write code when you are really trying to do if else, then if else, then if else, then if else, etc. For example, a typical scenario, we have like a bunch of ranges, and we try to decide, for example, based on the score value. If the score value is greater than 90, then the student gets an A. Else, if it's greater than 80, so we know it's not greater than 90, but it's greater than 80, then the student gets a B, else, and so on and so forth. By chaining the if-else statement, we can work through that kind of problem very easily. Okay. For the sake of time, I'm going to skip that example from the lecture, but it's detailed also in the reading assignment. It's just an example of a very, how to say, involved bunch of if else, if else, if else. Okay. So you are going to have if the status that you use to file your tax is 0, which corresponds to single, I think. So if you are a single tax filer, then you have all of those if else to allow you to compute actually the value of your tax. Then else, if you file married and jointly, then you have a bunch of code that is very similar to that to just compute your tax. And then else, if you file married but separately, there's another case, etc. So besides the fact that we got rid of all the curly brace here because we didn't need them, there was only one statement in every if or else part. This is like heavy. This is very heavy to read. Yeah, there's no indentation here that can really help you. So what the general structure is we're going to repeat 4 times, right? For status 1, 0, 1, 2, 3, we're going to repeat 4 times this huge bunch of if-else statement. Well, there is another syntax in Java called the switch statement. And the switch statement is very good at doing this kind of stuff. So switch an expression, right? And then you say, when that expression results in 0, case 0, colon, do something, break. If it results in 1, case 1, colon, do something, break. Case 2, colon, etc. So like the previous exercise, right? I would say switch the status. So it can be single, married, filling jointly, married, filling separately, and then divorce or widowed, I don't remember. And then you would put your giant if statement inside what is called a switch statement. So please take a look at the syntax. It's not that difficult, right? But it's weird. Switch an expression, open curly brace, and between the curly brace, is the expression equal to 0? Then do that. If it's equal to 1, then do that, etc. And we even have a default keyword that say, if you didn't match any of the above, then do this. Okay? So that's a new toy to play with. Question in the chat. With switch, can you only execute one path? Oh, no. And yes, you could nest switch statement. I don't know anybody who's done that. I mean, maybe I didn't look at the right example of code, but yes, you can nest switch statements. And your first question is very good. Can you only execute one path? No. But right now, I'm going to show you the clean version of the switch statement, which only executes one path, okay? So here's a basic syntax, okay? You put a switch expression here. You make sure that the data type of that expression is going to match the data type of all those values that you put here. The data types that you are allowed to use here are char, byte, short, and int. Alpha lie. There's a little star here. If you want the full story, go here, okay? But pretty much in this class, we're going to use char, byte, short, and int as data type of the expression. So the switch doesn't work for everything, right? So those values need to be of the same data type, okay? They need to be constant. So you cannot have like case 1 plus x. It has to be like a literal or something like that, right? And then the statement are what you want to execute for each case. But please note that at the end of each case, I have the break keyword, right? And this is what makes it magic in the sense that only one path can get executed. If every case ends with a break, okay, then if this expression is equal to, for example, value 2, then it's not equal to value 1, I skip, it's equal to value 2, I execute this block, and then break, I get out of the switch statement, okay? So Sam is trying to tell me that I'm going too long here and that I'm over time, so he's on your side. Let me just wrap up with just a few remarks with the switch and we'll be done, okay? That break statement, unfortunately, and this is going to answer your question, that break statement is optional. So then the problem is what happens when you don't use the break statement? And so is a default statement, but the default statement is easy to understand. If you run a switch, and none of the cases match the value of your expression, then you don't execute any of them. Default only execute as a plan B, you know, if you didn't match any of them and it's there. If you don't use default, then you don't have a default behavior. But the break statement being optional, that one is nasty. So let me show you first an example just to show some Java syntax. Yeah, default is essentially else. That's a very good way to put it, yeah. So let me show you like a good example of switch. This is like the super clean switch statement, okay? Give me a year. If year modulo 12 gives me 0, then I'm going to display this is the year of the monkey in the Chinese zodiac. Break, get out of the switch. If instead the result of this expression is a 1, then do this, rooster, break. And all of the cases are clearly separated. I don't even have a default because it's going to be a result between 0 and 11. I know for sure with modulo. I don't even have a default. I have a break everywhere. This is the kind of switch statement I want you to write, you know, in your code. And then this is a naughty version of the switch statement. I'm going to show that to you. There we go. This is a naughty version of the switch statement. This is a switch statement where we have some cases that are empty and they don't end with break. And then we have a case here that ends with break. And then we have a case here that does something. It's not empty, but ends with break. So this one, I'll let you take a look between now and next lecture, but just to wrap it up real quick to give you a hint, this one asks you to enter the number of a day in the week. You know, 0 is going to be Sunday, 1 is going to be Monday, 2 is going to be Tuesday, etc. And then it's going to tell you if it's a weekday or if it's a weekend. And the funny thing you can notice is that the cases don't have to be in order. Like, for example, here I say case 1, 2, 3, 4, 5, and then I'll go back to 0. So the order of the case actually could be whatever you want. But what's important is that case 1, if it triggers, does nothing. But if it had a break, it would do nothing and then exit the switch. But since it doesn't have a break, it cascades into the next case. So if I trigger case 1, I'm going to execute whatever is here, in this case, nothing. Then I'm going to execute whatever is here, nothing again, but there's no break, so I keep going. Whatever is here, no break. Whatever is here, no break. Whatever is here, so display weekday, and then break out of the switch. So it's like if I wrote, if case is 1 or 2 or 3 or 4 or 5, do this. But there is no way to do a or with the switch. So this is how we do it. And then if I match 0 or 6, then I display weekend. I don't have a break, but does it matter? No, because that's the last case. So I could cascade into nothing. So this is like a weird example. Again, you need to know that this is how a switch statement works. If you're able to read over people's code, we can write that a lot clearly with an if-else statement. So switch statements are good for some things. When you start having switch statement like that, you're better off, you know, using probably if-else. So as long as 1 to 5 are selected, so as long as this expression here, day, result in value 1, 2, 3, 4, or 5, yes, it's going to display weekday. And only weekday, because then it breaks out of the switch. If this expression, the variable day is equal to 0, 6, it's going to display weekend. And the order 1, 2, 3, 4, 5 here, I could completely shuffle it. I could say case 5, 4, 3, 2, 1, then 0, 6, or 6, 0, you know. I could shuffle things around as long as I have this structure, a bunch of empty cases, and then they cascade into one behavior. a bunch of empty case, they cascade into one behavior, I'm good. So it's actually position based. Okay, it's not the numerical order like I could write case 2, case 1. Okay, it's really the order in which you write them that's going to matter for the switch statement. Tell you what, I'm going to stop the recording here because I'm already 5 minutes over time, and I really do appreciate your patience, guys, but I don't want to continue abusing it. So I'm going to stop the recording right here, but I'm not going anywhere. So if you guys have questions about that weird switch statement, we can definitely experiment a little bit live in JGrasp, and I'll show you. It's not that complicated, but it's just weird. You know, there are a couple of things that can be source of bugs, so you have to be careful. All right, thank you everyone for your attention. I'm going to stop the recording, but don't go anywhere. If you have questions, I'll hang around. Thank you.